Welcome you all for the theory of computation session. Now we will be going to see about design a DPDA for a palindrome. So it is a deterministic push down automata, or design a PDA for the language L equal to W C W power R such that W equal to 0, 1, the whole flow. So it's any combination of zeros and ones. So the language here is palindrome. So the palindrome in the sense, what is the idea here is, we'll have the language which contains a string W. So W in the sense, here I am having 0, 1, 1, 0, 1, and we're having a separator C, and again the reversal of the word. So what is the reversal of the word? You are getting, and again 1, 0, 1. So it is a kind of a language which is called a palindrome. We have to check for this palindrome condition using PDA. So the idea here is, so see this, the idea here is you have to push all the symbols. What are all the symbols which is available in a particular word? We have to push all the symbols into a stack. So see here, so I'm having a stack here. So the top of the stack is, so initially the top of the stack is Z0, and I am pushing all the symbol, whatever 1 or 0 comes, we have to push into a stack. So 1, and you're having 0, and you're having 1. So for my case it is 1, 0, 1, right? So I have to push all the symbols into a stack, so until C comes, right? Once you have encountered C, so you don't need to push anything into a stack. After the reading of, you only make the state transition for indicating C has encountered. So after C has come, you have to check the reverse of the particular word. For when you see this 1, incoming symbol is 1, input is 1, and the top of the stack is the same symbol, you have to pop it off from the stack. After that, when you see this 0 as an input symbol and the top of the stack is 0, you have to pop it off. And if you are having a symbol called 1 and your top of the stack is 1, here pop it off. So we'll have this. This is the kind of scenario I have to check in DPDA. So why it is called a deterministic palindrome? Sorry, it is deterministic pushdown automata in the sense, here all the stack symbols are read. After that you will have the symbol C. So you have to determine where should you have to know the separator. You have to know where you have to stop the particular string. So that is why you are knowing the particular condition. So that is known as determinism. Okay. So you have to know the center point of the particular thing. That is known as DPDA. So we'll see how to make it, right? So the idea here is the concept is push all zeros and ones, push all zeros and ones into the stack until the C comes, right? After that, after C, when we see the input symbol, for example, if it is 1, if the top of the stack is 1, if the top of the stack is 1, TOS, right? Stack is 1, you have to pop the stack, you have to pop the stack Similarly, if it is 0, which means the input, if it is 0, so input is 0 and the top of the stack is also 0 of the stack, and continue the operation until Z0 comes, right? So until Z0 comes in the top of the stack. Okay, so this is the way you have to design. For this we'll have this transition diagram. So transition diagram here is, see this transition diagram. So our transition diagram, so the concept is push all zeros and ones into a stack until C comes. Oh, you have the center point over here. After C, whenever you are looking at 1 and top of the stack is also 1, you have to pop the stack. Similarly, if it is 0 and the top of the stack is also 0, now also you have to pop the stack until this operation is encountered, until it encounters 0 and Z0 comes in and top of the stack, right? So here I'm having, so see the transition diagram here is, so my starting state is Q0 and I'm having this starting input is 0, top of the stack is Z0, you have to have this, and input is 0, top of the stack is 1, so you have to check all the conditions. If it is first symbol is 1 and top of the stack is Z0, and you have to push like this. So 1 is a top, now top 1 is top of the stack. So similarly, if the input is 0, top of the stack is Z0, and you are getting after pushing operation, you are getting the stack as 0 is Z0. So, okay, so see here it is like this, right? So input is 0, top of the stack is Z0, now you are getting 0 is now, top of the stack is 0 now, right? So that's a part here. After that, after you are pushing whether is 0 or 1, right? So if you are having input is 0 and top of the stack is also 0, now you are having, so here input is 0 and top of the stack is also 0, now you are having this. So this is the 1. After that, input is 1, top of the stack is also 1, you are having like this. Okay, and another scenario is, if the input is 0 and top of the stack is 1, you are getting 0 1. If the input is 1 and top of the stack is 0 and you are getting 0, sorry, 1 0, right? Wait a second. So input is 0 and you're having so input is 1, top of the stack is 0, and now we are having 1 0. So this is this way. So you have to put all the combination of push operation in this particular state. After that, when you see after this combination of you put all the inputs, right? Now if you giving all the inputs to the push into the stack, so for this I'm pushing all the stacks 1 0 1 up to the separator C. I have put all these things into the side, into the stack. So once C comes, you have to make sure we will have the next operation, which is the pop operation. So we have to make sure that is a pop operation is coming on, right? So now you'll have this C. So all the input is elapsed. Now we are going to see the symbol called C, and the top of the stack is either 0 or 1, right? You have to check the condition. So if top of the stack is 0, you are not doing anything, so it is always 0, right? And you're having input is so there is, you're seeing only C, and the top of the stack is also C, right? And you're not doing anything. Okay, so here we have to check another condition also. Input is C and you are not the top of the stack is Z0. So what is the scenario here? So if you are not giving any input, this is also, if you're not giving any input, obviously Z0 comes, and the top of the stack is also Z0. So this is the general condition, and this is special scenario when you are not giving any input. Okay, only C is available. So in such case you are using this. Okay, so now Q1. So we are moving to Q1. So whenever you're coming from Q0 to Q1, you have to use this separator. So the separator has come. After this, you have to make sure it is an pop operation. So now see, if my input is 0, after C, if my input is 0 and the top of the stack is also 0, you have to pop the stack. So after that, input is 1 and top of the stack is also 1, you have to make sure it's a pop operation. So it's kind of null, right? After that, so that's why I'm having this. So whenever you're giving the you're pushing all the symbols 101 into the stack, after seeing the C, you're getting 101, right? So whenever you see this 1, you have to see the top of the stack and you have to pop it off. Again, when you'll have the same symbol again 0, so you have to pop another one. So you have to pop this. So once it is all done, right? So what will be existing now? So Z0. So we are having after all the input is over, you have to left out epsilon. There is no input, and the top of the stack is Z0, and you have to make two PDA acceptance. One is acceptance by null state and acceptance by final state. So if I want to make sure, you have to use this Z0 also. So you can leave the Z0, or sometimes you have to make sure you have to pop the Z0 and make it as null. Okay, so here I am having Q2 or QF, semi state. This is the way you have to use the deterministic pushdown automata. So for this you are having a transition function over there. So transition function. So you have to see all the kinds of transition over here. So this is a transition function. You have you make sure Q0 and 0, the top of the stack is 0, Z0. We'll have retain the same state Q0. You have to Q0 and also 0 is Z0, right? Okay. After that, input Q0, 1 is Z0. So 1 is Z0, you are retaining the same state, and you will have this 1 is Z0. After that, Q0, 0, 0. So top of the stack is 0, input is 0. So you are getting Q0, 0, 0, right? After that, you will have Q0, 1, 1. So it is Q0 and 1, 1, right? After that, you will have Q0, 0, 1. So input is 0 and top of the stack is 1. So now we will have 0, Q0 and 0, 1. After that, you will have Q0, 1, 0. So input is 1 and top of the stack is 0. So you will have this Q0, 1, 0. Okay, right? So you have to make sure all the conditions. So input is 0, is at top of the stack is Z0. You are retaining same state Q0, 0 Z0. Input is 1, top of the stack is Z0, and you'll have this 1 is Z0. Input is, you're retaining the same state, so all are the same state. And input is 0, top of the stack is 0, you have 0 0. And input is 1, top of the stack is 1, Q0 1 1. Input is 0, top of the stack is 1, 0 1. Input is 1, top of the stack is 0 1 0. So here are all the things we'll have. After that we'll have one more condition you have to check, right? So input is epsilon, there is nothing to read, right? Not epsilon, so here C, right? It's a separator. So input is C, and top of the stack is 0. You're moving to the next state, which is Q1. Okay, and whatever it contains, it's the same, right? And if it is Q0 and C is encountered, so input is C and top of the stack is 1, you're doing nothing. So you're making the state transition, which is Q1, and you're not making any operation inside the stack. So you'll have this, right? Okay. So only you make the state transition. So it's a C. Right. Okay. After the C here, now Q0. So after we'll move for this other thing, right? So now transition would be, so we are moving to the state called Q1. You see here my input is Q1. Now it's in configuration, right? Q1. Yeah, because we are reaching from Q0 to Q1 by using the separator C. So now my input is here, the state is Q1, and my input is 0. After seeing C, we are coming to a state called Q1. So when Q1 comes, we have to make sure it is a pop operation, right? So my input is 0, and my top of the stack, right? My top of the stack is also 0. You have to make it of Q0 epsilon, right? Okay. So again, if my input is 1 and top of the stack is also 1, we will have Q1 epsilon. Okay, now all conditions have been checked, and finally, so if all my input has been elapsed in Q1, so what is the next thing? We have to reach the final state. So my input is nothing, so my top of the stack is Z0 now, so it is going to be Q2 Z0, right? Okay. So let us now check the sample string. So sample string here is, what is my sample string? 101, right? 101C, 101. So this is my sample string. We have to check the sample string, right? Okay, so for this you will have Q0 101C 101. You are having Z0. So it's in production. It is known as turnstile symbol, and it produces what? So it kind of production, right? So when you see this one, what are all the things you are seeing until C, you have to push all the symbols into a stack. So and retain the same state. So Q0 01C 101 0 is it 0 is it not? After that we have Q0 1C 101, and I'm having, so it will go that side 0. So first 1, right? So it is 1. So it is also 1 Z naught. Okay. Next one. Q naught C101. So now it's 101 Z naught. After that you will have on seeing C, right? So see, on seeing C, I have already told this configuration. So on seeing C, and my input symbol is C, and my top of the stack, whether it is 0 or 1, we will go to the next state, but there is no operation on the stack, right? For this you have to follow this. So Q naught on C, and my top of the stack is 1. You have to make sure it is Q1 and 101, and we have 101 Z naught. Now you are into C, right? Q1, right? So when you are in Q1, you have to make sure it is a pop operation. So Q1 on 1, what is happening? So see here, Q1 on 1. So Q1 on 1, on seeing the input symbol 1 and top of the stack is 1, you have to pop it off, right? So the same operation you have to continue on this. So 1 on 1, you have to pop. So you will retain the same state. So 0, 1 and 0, 1 Z naught. After that you will have 0, 0. You have to pop it off, and 1, 1 Z naught. After that you will have Q1, so 1, 1 Z naught. So this is my Q1 epsilon Z naught. After that you will have this epsilon as an input symbol, right? So top of the stack is also now Z naught. So we'll move for, see here the condition here. So my state is Q1, and you'll have input symbol is nothing, it's an epsilon, and your top of the stack is Z naught. You're going to the final state, and you'll have on the top of the symbol only Z naught as left out. So Q2 epsilon Z naught, right? So now the string is accepted. Now the PDA looks like, so PDA Q epsilon tau del Q naught Z naught and F, right? So PDA equal to, so my Q naught is a set of state, right? So here Q naught, Q1 and Q2. So these are the set of state, and my input is 0 and 1, right? My input are 0 and 1, and stack symbol over here is Z naught 0, 1. After that you will have this transition function we have written here, and start state is Q naught, which means Q naught is a start state, and Z naught is a top stack symbol, initially stack symbol, and F here is Q2. So this is my PDA for this palindrome, right? Thank you.